Everybody, welcome back to another video in this series. Today we are actually going to be going over the movement functionality for our characters. So like we did in the last few videos, we got our crouch set up, we got our walk set up, we got our sprint set up and whatnot. So basically what we'll be going over in this video, and it's going to be a long one, is we're going to create the update movement function, which I will pull over right now to show y'all. We're going to be going over this today, where we actually, for this part, I want to do with y'all to get the gaits set up so that way we can get our corresponding walk, run, sprint enumerations and whatnot. So, you know, to go over it briefly real quick, when I open this up, and here we'll be setting up certain world speeds, or at least like world movements, like our IA move and a world space move, due to the fact that apparently for like locomotion testing and whatnot, or maybe there could be something a bit different in regards to the the movement in a world space. We need to get thresholds of stick drift, or not stick drifts, but stick deflections. So like gamepad movement, or at least the game joystick deflection. So like if you were to move up ever so slightly on a joystick, or left ever so slightly, there's like certain threshold numbers to them. So like typically if you have a joystick that's fully pressed forward, you are at a full stick deflection, and maybe you are like partially up, moving the joystick up, or partially down to where it's not fully deflected, but it is in like maybe a halfway point, or maybe like a 60% point, 30% point, something like that. So for stick deflections like that, we need to be able to get our corresponding gait movements for that, because on a keyboard and mouse you full on press a button, so you're going to be at a 1 regardless, like a full 100% of like a movement, unless you hit a corresponding button that deals with changing your character's speed to a walk and stuff like that. So that's enough of me explaining that. So let's go ahead and kind of dive right into it, right? So I'm going to move that back, and the first thing we do need to do is we do need to modify some of our movement input actions. So we do need to create a world space movement, and we're going to modify our our IA move, right? So let's go ahead and hop into our third person map template, or wherever you have your content browser docked, and we're going to go into third person inputs, and then input actions. And what we're going to do is we're going to duplicate the IA move to make it the world space move, right? So let's go ahead and hit Control D to duplicate that, and I am going to call it IA move underscore world space, just like that. And then once you get that set up, we are going to go back into our BP third person character template, and let's look for our move function, or our move input. And I'm going to move that over once I found it to kind of get it out of the way, and then move the camera down. So we're going to copy what the game animation sample project has. It's a bit confusing if you've never seen it before, but in here we have the default third person template movement input mapping, where we basically get our control rotation of how we rotate the character, and then we get the right vector, and then we get the forward vector. So basically what we're doing here, if no one's ever explained it in any of their videos, so you know how, if you've seen it before, when you go into move, you have your WSAD or your WASD, movements, right? So if we open that up in the IMC, and we open up our modifiers, open those up real quick, there we go. So you'll notice that we have a swizzle input access values, and then a gait, and then we have nothing for the D, right? So there's a reason for that, and it involves the right vector and the forward vector. So swizzle inputs typically are what allows our characters to move forward and backwards, because when you think about it, in like a plane, or like in a kind of not a mathematical sense, but think of it as like a plane, right? You have a 1D plane, a 2D plane, a 3D plane, stuff like that. I'm not want to make it too complex, but try to imagine those, right? like in a 1D plane, you would have an like an X value or a Y value, right? Because you're moving in a 1D space. In a 2D, you have an X axis and a Y axis. So basically, and then the 3D plane would be an X, Y, and Z. So, in saying that, our movement is on a 2D vector, so it's our X and Y. So our swizzle input basically manipulates the Y axis, because if we didn't have this, typically we would be, I believe, automatically moving sort of on a 1D plane like an X axis. So by setting up our modifier to a swizzle input axis value, we change it to moving on like a Y or a forward and backward motion, right? So that's what this does. So by having it as a swizzle input axis value, we get to move forward. So when we go to our S, then having the swizzle input axis value should allow us to move forward, but having it as a gate sets this button to move backwards. So this is how we get our backward motion, right? Because this would give us a +1 value of moving forward. This would give us a +1 value, but then we turn it into a negative in order to move backward. So then once you do that, then you have your forward and backward motions. And then for your A and D values, the reason we have A as the negate and not D is because D is technically your right vector. So if we go back onto the blueprint third-person character and have our right vector, that is our right side movement, or us moving the character to the right. So that's why we have nothing set for this, because this is technically our positive value moving on that correct plane. And then we set the A to negate because we are trying to move the negative or opposite way of that. So that's why we have it as such. So in saying that, then you can keep the movement input the way it is, nothing's going to change, but I want to redo it to match the game animation sample project, so that way we follow along and you know what's going on within that project. So let's go ahead and re-grab our IA move, because I am going to delete this, but what I'm going to do is copy it first, so that way I can get what I need out of it. So in this case, go ahead and we're going to copy the set control rotation, and we are going to set it here. And let me kind of extend that so that way we have everything good. And then we are going to grab a copy of the right vector and paste it here, and a copy of the forward vector and placing it here. So then what we are going to do is this is where pretty much kind of like how we get our rotations, or at least on the plane, or where we should be focusing our movement. So like you have the rotations of X, Y, and Z. The unfortunate part about this is I don't really have a good explanation for them, because I didn't really do my proper research to give you like a good explanation of this. All you need to know pretty much is that this is pretty much going to be our right and left movement, as I've shown you with our modifiers, and this is going to be our forward backward movement. But in here, we're going to take our control rotation and connect it to the Z value, the yaw input of both of these vectors. Then what we're going to do next is we are going to come from our action value, and we are going to look for normalize 2D. So pretty much this kind of sets, if I understand it correctly, the scale value. So like when you look in here how we have the scale value, and then we've had to separate this in X and Y, basically it normalizes these two values, or at least that action value, and allows us to split it here. So basically it takes whatever the value is here, normalizes it in here, and then pretty much kind of does the same thing. So like if we're doing a movement of 1 to our right, or 1 forward, or -1 backward, or -1 to our left, stuff like that. So then once we get that, we're going to copy our movement input, and we're going to copy it twice. So now pretty much it's almost kind of a similar setup to this. Instead of long, we're building it tall with just a few changes. So just kind of like how we have it in our original IA move, we are going to put the X to our left-right movement and our Y to our forward-backward movement. and then we're going to connect the vector values into the world direction of the move input, just like that. So now we basically have our forward, backward, left, right movement. After that, you're going to then connect the triggered into the first movement input, and then out of the output for the first movement input, you're going to connect into the input of the second movement input. So that is going to be our copy paste setup of the IA move. It does look confusing, but just understand that this is essentially doing the same thing this is doing. So if I, go ahead and get rid of these connections here and just have it set here, and I'm going to compile and save, and I'm going to run it, as you can see, we're still doing the same thing. So only a little bit is changed. We're no longer just getting the roll of our vector value for the right vector, but instead we're kind of getting the roll, I guess, in a sense, through here. Although, again, don't take me with a grain of salt on this part, just because, like I said, I haven't really thoroughly done the research for it to get y'all a proper explanation. I just understand how it works from my experiences with dealing with the game animation sample. So once we have that, I'm going to go ahead and delete this, and I'm going to I'm going to comment and call it our movement input. So now that we have that, we're pretty much going to copy and paste this ever so slightly, but we're going to be doing it for our world space that we're going to be creating, our move world space. So just like this, right? So since we do have that, we need to go ahead and call it within our third person template. So in a blank space, go ahead and call your IA move world space. And pretty much the only things we're going to get out of here is our movement input, and we're going to get the normalized 2D. So copy the normalized 2D and paste it in here and get both of the movement inputs. So then what we're going to do is, once you get those, we're going to hook the action value into our normalized 2D, and then we're going to set the X value to the left-right movement and the Y value to the front-backward movement. Then once you do that, what we're going to do is we're going to set values specifically in these movement inputs. So on here, we're going to set the Y instead to 1 and the X down here to 1. And then once you do that, we're going to connect our triggers and put them like so. And then we have our world space movement. So I know it's kind of confusing with how I put the directions, or at least the vector value of like an X here for a left-right movement and our Y here. I'm not quite sure why they did that, but pretty much I believe this has something to do with gamepad joysticks, and I haven't done a good enough research on this because I couldn't really find anywhere that explained this. But it basically does the same thing that our normal movement input does. So once you have that, I put a comment around it just to ensure that we know that it's our world space. So once you have that, now we have what we need to start the next part, which is updating our movement. So what we're going to do is we're going to go ahead and create a function for our update movement. So in the left panel, go ahead and create a plus to add a function, and we are going to call it update movement. So once you have that set, what we're going to do is we are going to drag off of here, and we're going to grab a sequence, because there's two things that we're going to run. So if I bring over my project that I'm currently working this all out on, you can see that we get our desired move gait here in this sequence, and then we also get our max speed calculations here. So that's pretty much how we're doing it. So let's go ahead and work on our desired gait. So what we're going to do then is we are going to go back into the third person map, and we're going to go into third person blueprints and go ahead and create a you should have a folder created called data, because we created the simple camera params structure file. So you should have that folder, so go ahead and go into it, and we're going to create an enumeration. Where is it at? It should be under blueprint, enumeration, and we're going to call it Gait. And we're going to open that up, and I'm going to set that right here. So basically what an enumeration is it's essentially, think about it as like, if you've ever coded before, a mapping of values. So so if you've ever seen Python before, or messed with Python before, you'll know what like a list is, right? Where you could put like a list of objects or numbers in it, but each of them are tied to like an index number, right? So you would have like, let's say your 0 index, which would be your first item in the list. Say that's like car, right? And then maybe your second item, which would be an index of 1, would be a truck. And then let's say the third item on the list is a van, and that index value is going to be 2. So in coding, especially if you've never coded before, a list would be basically starting from 0, going as far as you want, but 0, that first object, is going to be your first item on the list, then 1 is your second, 2 is your third, 3 is your fourth item, and so on and so forth, just like that. So basically what enumeration does is it enumerates or goes through that list of objects per index, or per its index value, so to speak. So what we're basically doing with the enumeration is we're creating a list of relevant, I'd say like relevant values. So kind of what I mentioned in a video before in this series when we did the camera params or enumeration is kind of the same thing, is we want to have a list of relevant or similar values of things that we'll be calling or like going through. So within this gate, what we're going to do is we're going to create 3 enumeration list items. So go ahead and put 3 enumeration values in here, and we're going to call the first one walk. We're going to call the second one run, and the last one is going to be called sprint. So these are our relevant items, right? Because we are trying to get our gait cycle, right? So a gait cycle is basically how you perform a walk or a run or a sprint. So typically it's like an 8-form cycle, right? Where you would have like when you go to walk, your first cycle would be stepping down with your heel first, then flat foot, and then the tips of your toes, to then up off the ground, to then your left foot comes down and repeats that cycle, and then you have a full gait cycle. So it's like 8 steps within just one big like movement step that you took. That's what a gait cycle is, and everybody has a different gait cycle when they move. Like maybe a part that's added to them is their hips sway, or maybe they touch down differently, maybe they start flat-footed, go heel toe and whatnot as they walk, run, sprint. So but that's essentially what we're doing here. So once you got that, go ahead and save. So you can go ahead and hit Control-Shift-S to save everything within your project. I did forget to mention that in earlier videos, but it's a good way to save everything if you haven't done so. And once you have that gate, what we're going to do is we're going to hop back into the third person template, and we're going to create a variable called gait. And we're going to change that variable to get our gait enumeration. So this is where we create a variable that holds those 3 values for us. So if we hit compile and save, as you can see in the default value, we have our values that were listed there. So we have our walk, we have our run, we have our sprint. So say, for example, I wanted to get these out and do something with them, right? So I can grab it 3 times and change it to walk, run, sprint. So say maybe I'm at a certain speed, right? And I want to set my gait to walk. So then it's like, okay, well, when I press the walk button, set my gait to walk, and then change my speed. So then you could set it somewhere else where it's like, so when my speed is this, perform a walk gait, or do the gait here, stuff like that. And this is very useful for animations and whatnot. So in saying that, we're going to be setting that in our character blueprint, which will then help us later in our animation blueprint. I still have not made it over to the animation blueprint with our research, but this will definitely help us in what goes on over there, and I'll even show you where it's located at in the animation blueprint. So we're going to create another function now called the get desired gait. Whoop, if I can spell. So once we have that, I'm going to hop into my thing and we're going to get this started. So the first thing we're going to do in here is we're going to get our moves. So we're going to get our IA move and our IA move world space. So our input actions, right? Because what we're trying to do is we're trying to get our action values. So basically our zeros and ones or anything in between. So that's what this is doing, is like anytime that we move on like whatever axis, it provides you an input of 1 or 0, which basically means on or off. So that's basically what we're trying to get, is those 1 or 0, that 1 or 0. So then go ahead and grab your IA move world space, and what we're going to do is we're going to get the vector 2D length from these, which basically it converts two values to like basically puts them together to just give us one value. So it kind of like straightens it out for us. That way we can then get our thresholds and whatnot for our movements. And then you're going to copy and paste that down here and put it into our IA move world space. So then once you have that set, what we're going to do is we are going to create a variable called analog, if I can spell, analog walk/run threshold. And let me get rid of that space. I didn't want to put spacings in here. And once we have that, we're going to change that to a float variable, because what we're trying to do is specify our threshold here. So with these world spaces, like I said, or the moves, you're going to get a 0 or 1 value when you move. So basically that means either you're 100% moving or you're 100% not. However, with the joystick on game controllers, like an Xbox controller or a PlayStation controller, that threshold can be different, because if you slightly tilt or deflect the joystick, like up, down, left, right, you can get values less than 100% or more than 0%. So that's why we have to specify our threshold here, because we're accounting for the joystick deflection. So go ahead and compile and save that, and the value we're going to give this is 0.7 for our threshold. That basically means like out of 100% of a stick movement, anything 70% or above means that we are full on like walking, running, whatever, or we're either walking or we're running. And the 70% threshold basically is our indicator that we are running, or even maybe going even faster, like sprinting. So go ahead and do control get or control left click and drag that on there, and then do it again. So now what we're going to do is we have to compare these values. So we need to drag off the vector length and get a greater than or equal to the threshold. So if our length or our movements are 0 and 1, if that's greater than the threshold, then we are running or we're like walking, right? So we're going to copy that and paste, and we're going to do the same thing down here. So now we have that. So again, just to reiterate and drive it home, we get the IA movement inputs here, and we grab the 2D vector lengths of their action values, which results in, like I said, in a value between 0 and 1. We then create a threshold to check against to see if we are greater than or equal to the threshold value to term our walking or running. So once you do that, I'm going to copy my comment and place it here just in case people want to comment, just to copy this comment down for memorization later, or to ensure what happens here. And then we are going to connect these into an OR boolean, because we want to say like, hey, if this or this hits that threshold, then do X. If not, do Y, right? So that's what we're trying to do here. So now what we need to do is we need to create another enumeration data file, right? So because this is where we then pick out what kind of speeds we want to do. So go back into your third-person map, or at least wherever you have your open content browser up, and what we're going to do is we're going to create a new enumeration file. So go to Blueprint, Enumeration, and we're going to call it E for enumeration, analog, movement, behavior. Just like that. And then we're going to open that up, and we're going to give this one 4 values. So go ahead and take out 4. And this is how we're going to set them up. So we're going to do fixed speed dash single gait. For our second one, we're going to do fixed speed walk run. For our third value, we're going to do variable speed single gait. And then for our last value, we're going to do variable, if I can spell, variable speed walk run. So basically, I'm going to copy and paste what each one of them does, because since I have them over on my other project. So you're more than welcome to pause once I've gotten all this done to write them down so you know what they do, but I'm going to go over each one of them. So for the fixed speed single gait, basically the character is going to move at a fixed speed regardless of the stick deflection threshold. So regardless of whether it's above the threshold or not, as if there's any movement, it's going to move at a single gait regardless. So with the next one, our fixed speed walk run, the character is going to move at a fixed walking speed with slight stick deflection and a fixed running speed at full stick deflection. So say that we don't reach our threshold, right? Our character will then walk. If we are above that threshold, then our character will run instead. So that's pretty much what's going to happen there. Then for the variable speed single gait, similar to kind of like how the fixed speed is, but basically full analog movement control with stick. The character will remain walking or running based on gait input. So it's pretty much a similar way of how the single gait is functioning, but it can go at different speeds, but it may not be like it might not be correct on like how fast you want the character to go. So basically if they're walking, it'll just go at like a certain speed. If they're running, it goes at this certain speed. So that's what it means by variable, is that those two can have their own speeds, compared to a fixed speed of a single gait where no matter what your stick deflection is, it's just going to move at one speed. The variable speed at least gives a speed to the walk and at least gives a speed to the run, but it's going to be basically at cap max regardless of like, you know, those speeds. So then with the variable walk and run, basically, like however you have like the stick deflected, however much you have it deflected, it'll go at a variable speed or whatever speed you're willing to let it go until it gets to like 100% of a stick deflection. So basically this is the best version of what you want. So once you have those, we're going to go ahead and we're going to save, and we're going to hop back in our third person template where we're going to be adding then a selection value set. So off of our or at least before our let's go ahead and make a variable called movement stick mode. And we are going to set it to our E analog movement behavior, because that's what we want. Once you have that, go ahead and compile and save, and we're going to control left click and drag out here. Then once you have that, we're going to right click and get a selection node, because we are going to be selecting the whatever speed that we want to go at depending on our gait or our movement. So basically in here, so as you can see in our selection node, this is kind of what I was mentioning earlier with our index. This is pretty much where it's getting that list value. And if you are selecting 0, you're getting that first option. If you're selecting 1, you're getting the second option. Third in line, you're getting that second in line, you're getting that third option, you know? So it's basically just like that. So as you can see, our fixed would be 0, this would be 1, this would be 2, and this would be 3. But basically, you know, in a non-programming universe, this would be 1, 2, 3, 4. So once you have that, what we're going to do is we're going to connect our OR boolean to the fixed speed walk run and the variable speed walk run. So that means basically, you know, if we are, depending on our threshold, whether we meet it or not will determine what kind of speeds we get, whether it's a fixed speed or variable speed, right? So then if we don't get anything out of that, or maybe something's wrong with it, then we want to set these to true, so that way, you know, if these happen first, we're going to get the fixed speed and variable speed walk runs. But if none of these are true, you know, then we're going to end up doing the fixed speed and variable speed of our single gate. So once you have that, we're going to right click and we are going to promote this to a local variable, because we don't need to call this anywhere else, so we can confine this to this function space. And with that, we're going to leave it as a boolean, and we're going to call it full movement input, just like that. So basically, that's a good gist of it, of what we got. And then what I'm also going to do is I'm going to copy paste my comment node in here for y'all to jot down so you know what this does. But basically how it says in here, we pass the true false value from our threshold check and determine if we have full stick deflection or not. If true, then we utilize the walk run selections, and if false, then we utilize the single gate options. We then pass those selections into the full movement input. Okay, and then now once we have that, so what I'm going to also do, I'm going to set that back to group movement and move that up, because we do need to be able to connect this into here. So then once you have that, now we can go ahead and work on our gate selections. So here we're going to call 4 branches. So if you hold B and click 4 times just in the spaces, you get our branches, right? So what we're going to do here is within our first branch, we're going to connect that. And then we're going to connect our true into the next branch, because, you know, if true, continue forward. If not, go down here, right? So then with here, our false, we're going to connect it in here. And then if we are true, we're going to do a gate option. But if false, then we're going to go down here and do the remaining gate options. So now what we're going to do is actually set up getting our desired gates. So in here, what we're going to do is we're going to right click and hit return node. And we're going to give it, we're going to call, if I remember correctly, our eGate. So right here where it says our output and our new param, we're going to go into here and we're going to call our eGate enumeration. And then we are going to call this return value, just because we're trying to return the current value, or the value that we want. So after you get that, you're going to copy and you're going to paste it 4 times, because there's basically, we have 5 ways of getting the gate that we want, depending on how much we deflect the joystick, right? So what we're going to do is we're going to work our way down. So if we have, so these are the values we're going to get now. So in your variables, go to your input and you're going to drag in your once to sprint here, your once to walk down here, and then your full movement input into the remaining branches. So we're going to, our first option is going to determine whether we want to sprint or not. If we do not want to sprint, then we're going to check to see if we want to walk. And so either way, if we want to sprint or want to walk, we then need to check the stick deflection, or at least our movement inputs, whether we're getting a full 1, a full 0, or anywhere in between, as long as checking where we're at with our thresholds. So then once you do that, we're going to connect these accordingly. So true to the first one, false to the second. This branch is true to the third one. This branch is true to the fourth one, and the false to the last one. And basically we're going to work our way from highest to lowest because we have sprint up here and our wants to walk down here. So if we do want to sprint and we have full stick deflection or movement, you can set it to run. However, one of the things that I have discovered is that say you want to sprint and you have full stick movement, well, then you're going to want to sprint, right? Because you want to be at 110%. It's like, hey, I press the sprint action button and I have full stick movement, so I'm going to want to sprint. But then say I don't have full stick movement, well, then we're just going to run, right? So now here, once we have that, so if we want to run, then we either want a full-on sprint depending on our movement stick, and then run for our, not 100% movements joystick deflection. So then on false, we're going to want to walk. So if that's true, if we want to walk, then we want to walk. But then if we have full movement input but we want to walk, then we're going to want to run instead, or like run or jog, right? Like the normal typical jog animation. And then say we don't have full stick deflection, then we are going to want to walk there. So let me pull up the game animation sample project to basically show you how they have it, so that way you can see basically why I'm given the sprint, right? So here in our game animation sample project, you can see here that theirs, is run, walk, run, walk. So when you hit play and you actually look at it, we're jogging or running technically. And if I hit shift, because they have the sprint input, we're not shifting, we're not doing anything, because, we have other stuff going on in here, but also too, they don't have the sprint set up in their current release of game animation sample. So once you have that, what we're going to do is we're going to compile and we're going to save this, and we're going to go back out to movement input, where now we're going to set our gait. So we're going to go ahead and grab our gait. So do Alt, left click and drag out of here. Oh, and before I forget, let's go back into get desired gait, and let me give y'all the comments that I had for this in case y'all do want to copy them down real quick. So for here, we're going to check whether we want to sprint or walk. And then for here, we're going to check if we have full stick deflection or not, depending, to choose the appropriate gait cycle. So then once we do that, go here into your function start, and we're going to call it a pure function. So the difference between a pure and impure function is how you can change or not change values, or at least not manipulate them to a certain degree. So say I uncheck this, right? Let me compile and save and go back to movement input. If I call out my get desired gait, this is what an impure function looks like, where I can change the target, I can go through stuff, modify it to whatever, and then return values. If I go into get desired gait, come in here and call it a pure function, and then compile and save. When we go into here, you can see how I can't make any more modifications. I can only get what it gives me. And that's pretty much what we want. Like, we don't want to modify it any more than what we already have in there. So once you have that, go ahead and off your sequence node, click and drag off there. So now we have our get desired gait set up. So that is pretty much it to it. I'm hoping I explained it as best as I could, and hopefully y'all were able to understand what was going on. So now, as a little treat, let me show you where they're actually calling this at to be able to update the animations properly. So let me pull up the game animation sample and let me drag it over. So if I go into the game animation sample and I'm going to pull up the ABP sandbox character. So now let me go back to the anim graph. So as you can see, this is pretty terrifying, right? There's a lot of shit going on in here. So you got your leg IK, you got your pose history, there's a lot of transformations going on. So basically where the gait is happening from is in the event graph. If we go to update states as you can see, here's where we're getting some of the stuff, especially right here. As you can see, we will eventually be getting into these other stuff when we eventually do come across the animation blueprint tutorial series that I'm going to try to do. But here is where we are essentially calling our gaits, where we've already have a reference to our sandbox character, where it's passing in our gait values, and then we are switching on the gait accordingly. So when we do a switch on the gait, that's what then allows the motion matching that they have set up to then select the appropriate animation set to do your walk, runs, and sprints. However, what I recommend not doing for the game animation sample project is connecting and setting up the sprint, because it does get glitchy, and I'll show you why. So if we go back into here and kind of like how we went through it and we set up our sprint, and let me compile and save, and I believe it is already connected. Yeah, it is already connected. So what ends up happening is, here's a little bit of my running. So once I start sprinting, he starts T-posing, although, he's posing pretty well, with our movements because of how he blends. There's other stuff going on in like the animation blueprint. Yeah, and there's also no database asset set for sprinting. So you would have to create your own sprinting series, or like your series of animations, or take something from like Mixamo. Even though it's going to look shitty, if you get the sprint one from Mixamo, you at least have a corresponding animation that it can play with that sprint. So that's why I don't recommend messing with the sprint yet until either they provide that update with all those sprint animations, or you make your own sprint animations yourself, or grab them off of another website. So that is pretty much going to be it for this video. What I am also going to do is, let's actually clean up our variables real quick. So with our gaits, what we are going to do is we're going to set them in our movement, and I believe, let me see, I think it's going to be within our input and our movement. So what we're going to do is we're going to set our gait into a movement category, and then the analog walk, run threshold and the movement stick threshold, what we're going to do is we're going to put those in our input section, because technically we are using them in regards to like our input. So that's kind of why they have them marked under the input section. So once you have that, pretty much good. And let's also clean up our functions, as we are now starting to get a lot of functions. So with our setup input, I'm going to go ahead and put that into an input grouping. And then our stats for debugging, because that's not in here, I'm going to put it under a miscellaneous section, so MISC. And then our update camera is going to have our update camera, so let's go ahead and put that as a camera section. And then our movement is what's going to have the get desired gait, the update rotation, and the update movement. So let's go ahead and put those under movement, since they do involve messing with the movement. So once you have that, you are pretty much done with this tutorial video, guys. I bet that was fun. Not really, it's a lot to take in, I know. But in the next video, what we are going to be working on is the calculating max speed, and I will show you briefly what that looks like from my project, right? So what we're going to be doing is we're going to be getting direction values and converting certain float values. We're going to be creating curve float. We're also going to be creating another struct, and I'm going to explain the difference in this one compared to game animation sample. And there's a few other things that we're going to do and set in here, but this one's also going to be a long video, so definitely buckle up your seatbelts for that one. So other than that, guys, thank you for joining me in this video, and thanks for sticking through with it. In the next video, I look forward to seeing you then. Take care. Bye.